Okay, so our new drawing for the day. We're looking at defining what's called a compound, an intersection of two angular surfaces, or compound angular surface, which is this edge right here, defining the position of that edge. To define the position of that edge, we're going to do just what we have been before. We're going to define angle of rotation and angle of tilt. To do that, what I'm going to do is I'm going to magnify this corner right here over here. So that's that edge going up there. My angle of rotation, if I'm looking at it as this being across the bottom of that, my angle of rotation is right here. So that would be the line going corner to corner if I'm looking at that as a box. It would be the line going corner to corner across that. And then my angle of tilt is the one that goes up and down here. So I need to find those two angles. There are two different ways this can be defined for me. The first way we're going to define it, I'm going to give you this angle here and this angle over here. So this angle here, I'm going to define as 24 degrees. This one over here, I'm going to define as 34 degrees. So I'm going to do this. I'm going to do that. This is the 24-degree angle. That's looking at from this side. This is looking at from this side, where this is the 34-degree angle. And of course, technically, it's going to look something like this. But anyway, just like we have in the past, this is actually a lot simpler than the ones we did yesterday, because all we're going to do, we're going to fill in this triangle. We're going to define a depth here, which 10 millimeters usually works pretty well for us. And we're going to find these dimensions. I'll call this A and B. How do I find dimension A? So tangent of 24 is equal to 10 over A. So yes, it'll be 10 divided by tangent of 24. $22.46. B will be 34 this time. It was 10 over B. So yes, 10 divided by tangent of 34. 14.83. Now what? Well, basically what we're doing now is we're just cutting this here, and we're looking at that corner, and that corner is just a box. So we're looking at this as our angle of rotation, which is going to be this dimension, the 14.83, and this dimension, the 22.46. What are we going to do with them? Inverse tangent of perfect. Inverse tangent 14.83. So second tangent 14.83 divided by 2.46. 33.44 degrees. Our angle of tilt now, if I put this in as the angle from here to here, I know this is my 10, but I don't know anything else, do I? Yet. But I could find this if I just wanted, it would be my theoretical length, even though it's not going to be anything. I'll call that L would be the square root of 10 squared plus 14.83 squared plus 22.46 squared, correct? So second square root 10 squared plus 14.83 squared plus 22.46 28.46 squared equals 27.10. And now R, or not R, T I should say, is the inverse cosine of 10 divided by 27.10. $68.3435. Something's not right there, is it? The 10 not square? Oh, it did not, did it? So second square root, 10 squared plus 14.83 squared plus 22.46 squared. 28.71, that better? So this would be, so let's try that again. Second cosine, 10 divided by 28.71. 69.62 degrees, look better? That's not inverse cosine though, is it? That's the opposite side, not the adjacent side. So it should be inverse sine. When we were looking for this angle up here, it was inverse cosine, because then it was the adjacent side. Yeah, so what we just found, that 69 degrees, was that top angle. So T should really be the inverse sine of 10 divided by 28.1 or 701, which is going to be 20.38 degrees. Correct? That's T. Not so bad. What if, instead of being given the angles, what if I'm given this? That as I look at this from the top, I am given that this is 28 millimeters, 34 millimeters, and that this here is 72 millimeters and 58 millimeters. And, of course, I'd have to be given that height from here up to there from going vertically. We'll give that height as 32 millimeters. Bless you. Well, these dimensions allow me to define my box again here. This, of course, is just my 32 millimeters of height. What's this dimension here going to be? Remember my box. It's just that part right there. You bet. Subtract those, that's going to be 30. How about this one? 72 minus 34, which will be 38. Now, we can find our angle of rotation pretty simply. And you can find our angle of tilt. Find the angle of rotation and the angle of tilt quick. What'd you get for the rotation? R is going to be the inverse tangent of 30 over 38, which is, not everybody at once, 38.29 works for me. For the angle of tilt, you need to know something else. What do you need to know? The theoretical length, which will be, this is the square root of 32 squared plus 38 squared plus 30 squared. Comes out to be how much? 5803. So then the tilt is the inverse sine of 32 divided by 5803, which gives us 33.46. Well, good. We have some really good news. This is our last compound angle topic. You are about to get your last compound angle homework in your packet, page 416 through 418, 1 through 14. Coming up tomorrow, you will have your last compound angle test. And then starting on Thursday, we will start your final test.